If y'all want to see the tops of the rocks, like what we can't see, there's some pieces that have broken off over there that are really cool.
And I'm glad you're hanging out because I think I want to do
a little zoom in.
Yep.
Okay.
Yeah.
Should we be concerned?
It looks like a blue jay of some kind. I know there's like a mountain jay out here that's really dark colored. Yeah.
Yeah, pressing.
So, live, we see it and heard, so
Ready.
All set? All right.
Green says
Here
pretty
we
wall.
are at our next outcrop on our stratigraphy tour. This is the Moenkopi formation. It is beautifully distinctive for its bright red, red-orange color. And there's a lot of really interesting stratigraphy going on even inside of this unit. And that's one of the things that we're looking at here. Dave has some really neat samples that show some of the significant variations that you can see in the rock units here, where you can see a lot of changes in depositional environment, from this one that almost looks like some sort of breccia to this one that's really fine-grained, and they're all sort of interbedded in this outcrop. And then we will hop over to Anna here in a second, and Anna can give you a little bit of a tour of the site, and then maybe we can go check out the beautiful ripple marks in a section just down from here. So, thanks, Dave.
Mm-hmm.
Wait. Checking grain size. Oh, this is open. Keep talking.
Oh, okay. I was gonna say, over to you, Anna.
Maybe about the difference of what we're seeing in the... Do you want me to sit
Yes, please. Can you put this in?
Right.
Thank you.
But
Is that top one?
I didn't want to step on Anna's toes.
Thank you.
I got you.
All right. What am I doing?
You said you wanted to?
Yeah. So the biggest thing that stands out here compared to the other sites is red. It's looking pretty consistent in color, although there are some white patches that tend to be horizontal. Regarding grain size, it's I would describe it as fine sand. I just looked and it's like 100 to 60 microns ish. Did you do up close?
Of those little samples Dave had, we looked at these two. Yeah.
Not too close, because then it'll be out of focus. I can zoom into you. There you go.
I don't know if y'all can see the lineations here. We are seeing that on the wall, and it's all pretty much perfectly horizontal. There's variation from top to bottom. There are layers that are chunks like this, and then there are some layers that are so finely bedded, really, really thin layers, that they're pretty much just crumbling off.
Do you feel comfortable showing us which crumbled and which...
Yes. So that's not a good example. This is a good example. So this is a more, well, that's a bad example. These are more solid pieces. where it kind of all looks the same throughout. Some of them have those lineations. And then this, I just broke off of the wall.
Oh, cool.
Can you see the layers in here?
It'd be hard to balance the shadow. What about like right behind you? There's a little bit of sunlight.
Like here?
Yeah, in the sunny patch.
In the sunny patch. So we can see layers here, and we'll send you pictures as well if it's not coming through. The layers are kind of like centimeters or smaller, tall, and they're just crumbling. And I'm seeing a pattern of it as well. In between, the finely bedded layers tend to be more recessed.
Yeah, let's talk about that a little bit. Like, you know, slope formers versus bluff formers. This is a really great location to talk about that on the small scale and what it looks like in the big scale.
Yep. So the top unit is a really good example of these kind of massive pieces that don't have this fine bedding, and everything else is sloping.
Right, so you can see how the weathering is dramatically different of some of these units, right? You can see our more cohesive units are standing up to weathering a lot better than these crumbly units, which are weathering out just, you know, significantly faster than these other units. And you can see this in big scale and little scale. You start watching, you know, the geology around your area, the geology around this area. We'll pass some areas where you just see slopes of material, and we'll see other areas where we have these big bluffs or cliffs. It all has to do with the tenacity of the rock and how easy or hard it is for that material to erode. Yeah, I think now would be a good time to toss it to you all. Let us know if you have any questions while we're here.
Can I add one more?
Yeah.
So for the most part, everything that we're seeing is pretty consistently horizontal, but I think it's a little bit too far to show up on the camera, but we will share pictures. There is one location where we see bedding at an angle.
Right.
And we're going to see a lot more of that in the Coconino sandstone as well.
Right.
Why is the bedding at an angle significant?
No, yeah, so it's that's something called cross bedding, which is basically fossilized sand dunes. I kind of would need to draw it to describe it, but as dunes move, or as the wind blows, sand moves, and the dunes migrate in the direction of the wind. And the sloping side of the dune, it leaves behind a trail. So as the dunes migrate over each other, where that side of the dune used to be gets left behind. And so when we see cross-bedding, it can be indicative of wind direction and direction of dune migration, but it also can be indicative of the depositional environment. So that's telling us that that unit deposited in a desert, somewhere with sand where wind processes were dominating, and we can learn about ancient climates.
Is that the type of stuff that you're studying on Mars?
Similar, yeah.
A little bit about that?
So my research, so on Mars, the atmosphere is very thin, but we do still have sand transport. The wind is able to carry sand, and we have sand dunes on Mars as well. Sand dunes as well as sandstones, remnants of ancient sand dunes. And so my research is trying to use the composition of the sand to track where the dunes came from, try to find their source rocks. So tracing those sand transport pathways. And I'm doing that using using Mars sand analogs from places like Sunset Crater, where we're going tomorrow. I take them into the lab, and I do experiments that simulate the effects of wind transport, aeolian transport on the sands, and I look at how they change over time And so I'm going to try to apply that to the remote sensing data on the composition.
Cool. Do we have any questions from our online folks?
So far, we haven't had any questions coming in, but
Okay. Well, we can always answer them on Discord as well, especially since we're running a little bit behind schedule. A quick note, we are currently on historic Route 66, which if you don't know what that is, I suggest you Google it. It's also known as the Mother Road. Before the advent of interstates, this was the primary artery to go from east to west across a huge chunk of the United States. There is a lot of Americana, a lot of sort of culture attached to this particular section of a very historic highway. So
From Chicago to Los Angeles.
Yeah.
And the last remaining unbroken stretch of Route 66 is here in northern Arizona.
that's right. So this is like, if you want to actually drive the original Mother Road, this is the place to do it. A fun little fact for later in the field course, when we go out to the mystery site, we will use an original section of Route 66, so unpaved, unmodernized, that was basically replaced with the interstate later on. But for just a little bit, we'll be on the original asphalt of Route 66. So.
your questions just came in there. Just checking with you. CC was asking, so this is an Aeolian deposit? Is that correct? Aeolian?
Yes.
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 I believe primarily.
So to answer Cece's question,
Oh.
because she can't hear
Oh
us.
yeah,
Oh,
yeah.
sorry, CC. Yes, this is primarily an aeolian deposit.
Yeah.
That's us then.
All right, so we're out here at the Moenkopi, and we are gonna head out to Meteor Crater, get some lunch, and be back online with a museum tour this afternoon.
Did you want to see the ripples?
All right, see you guys.
Wait. The ripples?
We can post them to
Okay.